Primary biliary cholangitis and cirrhosis, sometimes just shortened to PBC, is this autoimmune disease where the T cells attack the cells that line the smaller sized bile ducts in the liver. As the cells are damaged or destroyed by immune attack, they start letting bile leak through their tight junctions and into the interstitial space, where it can get into the blood and other liver cells. This can cause inflammation and symptoms that are similar to cholestasis and obstructive jaundice, both of which there's this disturbance in bile flow. At first it presents as chronic inflammation, which is where it gets the name cholangitis, for inflammation of the bile ducts. But advanced stages of the disease leads to cirrhosis as more cells are destroyed, both from the autoimmune attack and from infiltration of bile. As with a ton of autoimmune diseases, the exact reason why these T cells start attacking these bile duct cells is unknown, and it's likely related to genetic predisposition in combination with environmental triggers, and is associated with other autoimmune diseases like autoimmune hepatitis and Sjogren's syndrome. And PBC tends to affect women at a much higher rate than men, at about a 9-to-1 female-to-male ratio. For some reason that is yet to be completely figured out, in almost all cases of PBC, your body creates antibodies to mitochondria, specifically a mitochondrial protein called PDC-E2. For that reason, one of the most notable markers in PBC are these anti-mitochondrial antibodies, or AMAs, in the patient's blood. As many as 95% of patients with PBC have these AMAs in their blood. Why, though, are the bile duct cells specifically targeted? Don't all cells have mitochondria? Shouldn't these AMAs be targeting all cells then? Well, one theory is based on a concept called molecular mimicry, where the antigens that bring about this autoimmune response are really similar to another protein, but different enough so that the immune system gets confused and thinks it's a foreign version of that particular protein. As an example, here's two people's cells. They both have this triangle protein, but they have different colored triangles. Each person's immune system knows that these are their own proteins, their own self-proteins, that they shouldn't attack. But they have antibodies for proteins that are very similar, but definitely different from self-proteins. So like person A has red, yellow, and blue, but just not green. And person B has green, yellow, and blue, but not red. So both these people's immune systems are like, yep, these are all self, so we're good here. But now say person B's red triangle turns into a green triangle instead. The immune system's like, weird. That's not red. That must not be ours. And so the green triangle antibody binds it, and the immune system kicks in, destroys the cell, and starts making a ton of these matched antibodies. So now applying this concept to PBC, you've got these AMAs for foreign versions of the PDC-E2 protein in your mitochondria. So like maybe your PDC-E2 is a red triangle. So you don't have the antibodies to the red triangle PDC-E2 because your immune system knows that red equals self. So the theory is, and mind you that this is definitely a theory, on why patients with PBC have a ton of these AMAs in their blood for this PDC-E2, is that some infection, or maybe a chemical in the bile ducts, an environmental trigger of some kind, damages a bile duct cell in such a way that now it shows this protein that happens to be really similar to PDC-E2 in structure. So maybe it's a triangle, but it's different enough to be non-self. So maybe it's a green triangle instead of a red triangle. And this triggers an immune response to this particular green triangle protein, which remember is similar but not the same as the red triangle protein in the mitochondria. And so the immune system starts pumping out these green triangle anti-mitochondrial antibodies, or AMAs, even though the target antigen isn't even necessarily from the mitochondria. It's just sort of mimicking the structure of the mitochondrial protein. Wild, huh? That's the theory anyway, and sort of helps explain why just the bile duct cells are being attacked, and not just all cells in general. As to the complications, a lot of the clinical findings are related to the leakage of bile and general inflammation of the liver tissue. For example, jaundice typically happens after most of the bile duct cells have been destroyed, since now the bile and conjugated bilirubin is leaking into the blood, right? Similarly, other things in the bile can get into the blood as well, like cholesterol. Cholesterol can deposit in the skin over time and lead to xanthomas. But for reasons that aren't super clear, a lot of patients actually get pruritus, or itchy skin, even before the jaundice sets in and the bile salts get a chance to deposit in the skin. Again, it's unclear what causes this early itchiness, but eventually as bile leaks into the blood, bile salts will also contribute to the pruritus and itchiness. A high proportion of patients also have joint pain and arthropathy, which may be connected to other autoimmune diseases like rheumatoid arthritis. In addition to these AMAs and components of bile getting into the blood, it's also pretty common to find both alkaline phosphatase and gamma-glutamyl transpeptidase, or ALP and GGT. Both of these are normally found in the bile duct cells, so when those cells get damaged or die, these enzymes can be released and get into the bloodstream. Ultimately, the issue with PBC is that over time the immune cells wreak havoc on the bile ducts, and all this bile leakage slowly but surely damages the liver and surrounding tissue, and gets into the blood. A couple medications can be used to help kind of reduce these symptoms of bile components like cholesterol getting into the blood. One is ursodeoxycholic acid, which reduces the body's absorption of cholesterol, and the other is cholestyramine, which binds to cholesterol and allows it to be more easily excreted. And finally, if the damage to the liver has gotten severe enough, a liver transplant might be recommended. One last thing, if damage has been done to these bile duct cells, but the cause isn't due to an autoimmune attack, like maybe if the ducts are obstructed for a long time by a tumor or something, then it'd be called secondary biliary cholangitis and cirrhosis. Secondary PBC would present with a lot of the same symptoms and complications that crop up from bile being released from the bile ducts, right? But one very important difference is that there wouldn't be any antibodies to mitochondria in the blood, right?